Okay, now, so if we look at the second example, 11.2b, okay, same thing, you have to make use of Pythagoras theorem. Okay, in this scenario, instead of a cone in a hemisphere, you have a cone in a complete sphere. Okay, with cone of radius 15 cm and sphere of radius 17 cm. Okay, first you're asked to find the height of the cone. Okay, so when you see a triangle in a sphere, okay, what you do is to draw a line from the center to the corner of the triangle. So center of what? Center of the sphere. Okay, so this is what we call the center of your sphere. Okay, so same thing as how you will view a circle. Okay, what I can view this as is, because this is a 2D diagram, okay, this is your center of like a circle. Okay, so which means this length itself, okay, I can take it to be your radius of your sphere. Okay, okay, next. This is also the radius of your sphere. Okay, but if I want to find the height of the cone, I am still missing this portion here. Okay, which I highlight in blue. Okay, so this is the portion that we are missing. How do I find this portion? Okay, so these two are at the same horizontal level. So I draw a horizontal line. You use your ruler to draw in your notes. Okay, so essentially, if you all realize, this is also a right angle triangle. Okay, where this is your radius of your sphere, which is 17. Okay, this is what you want to find out. Okay, so let's say we label it X in this question. The base of this triangle is the radius of your cone. Okay, so 15. Okay, that's how you get the x squared plus 15 squared equals to 17 squared using your Pythagoras theorem. Okay, then from there you work out what is your value of x, which is worked out to be 8. Okay, once you have found out your value of 8, okay, your height of your cone is this blue portion here, which is 8, and this red portion here, which is 17. Okay, so you take 8 plus 17, you get 25. Okay, that's how you find the height of the cone. Okay, next, you want to find the volume of the cone. So think about what you have in your formula for volume. 1/3 pi r square h. You have r, which is given to you is 15. You also have h, which you just found. Okay, so throw in the formula and then sub in the values that you have. It's that simple. Okay, and then you key in the calculator, you should get 5890. Okay, then lastly, curved surface area of the cone. So if you recall, for your curved surface area, okay, your curved surface area of your cone is pi RL. So you have R already, right? Which is 15. L is this length here, which you don't know. So we need to find this length. Okay. So if you look at the bigger triangle now, which is this big triangle that's outlined. Okay, so I'll draw it out for you. Okay, so in the exams, if you all cannot see it from the diagram, you can always draw out the side to make it clearer for yourself. Okay, so same thing is a right angle triangle. Then the height of your cone you found earlier to be 25. Then this radius of your cone, which is 15. Okay, this is what you want to find, which is L, your slant height. Okay, so work out using Pythagoras theorem, what's your slant height? Same thing, because if you square 850, you don't get a very nice number. It's a never-ending decimal. Okay, so I leave it as square 850. Then I throw it directly into my formula. Okay, and then you work out your curved surface area and round up to 3SF. Okay, so one important thing to take note, okay, although yes, this chapter is all about throwing in formulas. Before you even start writing in your formula, okay, think about what you need in your formula. Do you have the radius that you need? Do you have the slant height that you need? Do you have the height of the cone or pyramid that you need? Then you go and work out. Okay, don't rush into throwing in your formula in. Okay. Okay, now we look at example 11.3a. Okay, so using similar triangles to find sides of your figures. Okay, so if you all recall your similar triangles. Okay, this is under your chapter of congruency and similarity. Yeah. Okay, if you all forget what is similar triangles. Okay, so you have a cone with a hemisphere filled up to a height of 7 cm. Okay, the height of the cone is 12 cm. Okay, then you have the radius of the hemisphere, which is 5. Okay, find the radius of the water level x cm as shown in the figure. Okay, so essentially, okay, there's a typo. Okay, so the x is referring to this cm here. Okay, essentially, what is the radius of the cone for your water level? Okay, so in this scenario, you use your concept of similar triangles. So if you were to fill it to the brim, which means up to the portion of the base of the hemisphere, okay, it's given to you that this big triangle is 12. All right, it's written for you here, 12 cm. Okay, then your base obviously is the radius of your hemisphere, which is 5. Okay, then this is the new one that the new r they are looking for. Okay, so you all can just replace it with x as well. Okay, so change all this to x. Okay, wherever you see the r. Okay, okay, so if you look at what you have, okay, these two similar triangles, if you all recall for your similar triangles, okay, the ratio of their lengths are the same. That's why if you take x over 5, which is the base of the two triangles, over 7 over 12, which are the two different heights of the triangle, the ratios are the same. Okay, then from there, work it as how you would to solve for x. Okay, cross multiply, meaning you multiply 5 over, that's it. Okay, that's how you get 35 over 12 cm. Okay, then remember to simplify this to the simplest form. Okay, put it in your mixed fraction form. Okay, so just add in an additional step. Okay, 2, 11 over 12 cm. Okay, the reason why they leave it as the answer as such is because normally in questions you probably need to use it again. Okay, unless it's a part of the question itself. Okay, if it's just in the middle of the working, you can just leave it in this form. Okay, but final answer always has to be in simplest form. Okay.